Hello everyone, very glad to be here to share with you our recent work about visual tracking based on recursive least squares estimator aided online learning. This is a joint work partially supported by the Visiting Your Faculty program from MSRA. When we talk about online learning, we mean the algorithm or the model will adjust and update itself upon each new chunk from the data stream and will forget old data based on a specified time frame so as to adapt to new patterns. Since it is just right for visual tracking, online learning has been playing an important role in the state-of-the-art trackers, such as MDNet style and Atom style trackers. Today we are going to investigate an ideal online updating method with memory retention, and the main advantage we can exploit is the ability to not forget the old knowledge about the target after forgetting the old data. The motivation behind this is that a naive online updating method without memory retention, usually called tracking drift, due to overfitting to some non-accurate samples. However, how to conduct ideal online updating with memory retention is hardly investigated in the literature. That's because the straightforward way of incorporating the memory in visual tracking will encounter the significant computational overhead and slow convergence, which prohibits high tracking speeds. Some MDNet-style trackers use two update strategies to make a compromise between memory retention and tracking speed, while updating with Minibatch HDD. In our work, we are the first to propose an improved mini-batch HDD algorithm for fully connected network learning in a recursive fashion without too much computational overhead. Its memory retention property can spontaneously reduce the risk of overfitting in online tracking. To this end, we first elaborate on how the HDD optimization is related to normal occurrence in least squares estimation, and by doing some simplifications, we can represent each layer by the system normal occurrence in a uniform format based on some derivations. With this representation, we can further expand the previous normal occurrence to include inputs collected from all the historical observations so that it is equivalent to optimizing the cost function computed over all the training samples ever seen. In our improved mini-batch HDD with memory retention, the matrix P serves as a projector to modify the updating direction so that the old knowledge about the target will not be forgotten. This recursive online updating method can be seen as a plug and play into existing methods. We apply it to replace the original mini-batch HDD in the online tracking phase of RTMDNet, and we leave all the other parts almost unchanged, especially under the same off-the-shelf trained network model and hyperparameters. Note that we do not need maintaining the long-term memory to achieve robustness anymore. We see a statistical improvement over the baseline by running the entries 50 times due to the stochastic nature of RTMDNet to intuitively show how the overfitting risk is reduced at each epoch of the updating. We also tested the collected samples in the initial frame, and the plots clearly show its memory retention property. More comparisons of the VOT and UAV benchmarks also show the statistical improvements over several runs, and we do not require pre-training and fine-tuning to achieve that. For more information, please refer to our main paper, and you can reach me through the email shown here. Thank you very much.